Today we'll start a new chapter, solids. Solids is one of the simplest chapter in chemistry of class 12th. Only thing is that you require a bit of imagination because we'll come across some three-dimensional figures. So let us start the chapter. So the first thing is, what are the three states of matter? Solids, liquids and gases. Gases and liquids you have already studied in class 11th in detail. Gases you studied in detail and liquids some part, and the remaining portion of liquids you will be studying in physics. So this year now in class 12th we are going to deal totally with solids. So what is a solid? How will you define solid? In case of a solid, the constituent particles are very closely packed. What do you mean by the constituent particles? The constituent particles are, it can be atoms, molecules or ions. Okay. So in case of solids, the constituent particles are very closely packed. In gases, you know, they are loosely packed, and in case of liquids, it's in between gases and solids. So in case of solids, the constituent particles are closely packed. So that's the definition for solids. In case of solids, the constituent particles are very closely packed, which gives rise to different properties for solids. So we'll see the properties of solids. Now what is the first property? I'll be writing and I'll be explaining also. Okay. The first property is solids have definite shape, volume and size. So the volume, shape and size of solids are definite. Shape, comma, size, volume of solid is what? Definite. So this is the first property of solids. Shape, size and volume are definite. Now the second property you see, can you compress a solid? Solids cannot be compressed. Why we cannot compress a solid? Why? Because the intermolecular force of attraction is very strong, because they are closely packed. The constituent particles are very closely packed. So the intermolecular force of attraction is very strong. So you can't compress a solid. So the compressibility is low, very low. Compressibility of solids is low. Next, 3. Can it be flexible? When the intermolecular force of attraction is very strong, means it's not possible that solids can be what? Flexible. So flexibility is also what? Low. So flexibility low. And the fourth one is diffusion. Now we know when you spray perfume, what happens? The entire room has got the fragrance of what? The perfume. Why? Gases, the molecules in a gases are what? Free to move. So that is the reason why when you use a perfume, what happens? The fragrance is there in the entire room. That means gases can diffuse. So that is possible in case of solids. In solids cannot diffuse. So diffusion is also what? Low. Then the fifth property is, see here, in case of solids, the constituent particles are closely packed, or the intermolecular force of attraction is very strong. So tell me, is movement possible? So there is no translatory motion. No translatory motion. They can only vibrate in mean position. Can vibrate in mean position. So these are the properties of what? Solids. Solids are those in which the constituent particles are closely packed, as the intermolecular force of attraction is very strong, which gives rise to the properties of solids. So the properties are what you see: shape, size and volume is definite, compressibility is low, flexibility is also low, diffusion is also what? Low. All these are due to strong intermolecular force of attraction. So what can you say? Solids are rigid. Then there is no translatory motion in case of solids. Why there is no translatory motion? Because they are closely packed and therefore they are not free to move. Only they can vibrate in what? Mean position. So see, solids are classified into two categories. One is crystalline solid crystalline solids, and the second one is amorphous solids. So solids are classified into two categories, crystalline solids and amorphous solids. I'll just make two columns and I'll explain by differentiating crystalline and amorphous solids. So listen carefully. So here I'm going to take crystalline solids. And here amorphous solids. I'll just make a crystalline solid. See here. So what I have made here is cation, anion, cation, anion, cation, anion, cation, anion, cation, anion, cation, anion. That means the constituent particles are what? Ions. Okay. Next I'm going to arrange it like this here. So next I have arranged this below it. Then the third one. So that is arranged. Okay. Then the next one I'm going to arrange it here. So different arrangements. So what do you observe here? The constituent particles are arranged in a systematic pattern, or there is a discipline in the arrangement. Positive ion, negative ion, then positive ion, negative ion, positive ion, negative ion. Now see the next row also, positive, negative, or cation, anion, cation, anion, cation, anion, cation, anion. Again here also it's the same, cation, anion. So there is what? A regular pattern is followed for the arrangement of what? Constituent particles. That is, there is a discipline in the arrangement of the constituent particles in case of a crystalline solid. So that is the first definition for crystalline solid. That is, in crystalline solid, the constituent particles are arranged in a regular pattern, or there is a discipline in the arrangement of the constituent particles. That is, they follow a definite pattern. So that I am going to write here, the constituent particles are arranged in a regular pattern. So they follow a long range order. So understood what is long range order? Long range order means the arrangement remains same throughout. From the beginning till the end, the arrangement will be what? Same. That is, the discipline is maintained in the arrangement. So that is the meaning of long range order. So in case of crystalline solid, the constituent particles are arranged in a regular pattern. So they follow a long range order. Now let us see in case of an amorphous solid. I am just taking the same cation and anion only. First cation, then anion, then cation, then anion. Then you see sometimes everything is cation. Then comes anion, anion, then cation. Then here some cation, cation, cation. Then comes anion. Then again anion, anion, anion. Then a cation. So what do you observe here? Is there any regular pattern is followed? There is no regular pattern in case of an amorphous solid. That is, they are arranged in a not in a systematic manner, or there is no discipline in the arrangement of the constituent particles in case of an amorphous solid. So how will you define an amorphous solid? the constituent particles are not arranged in a regular pattern. So they have short range order. What do you mean by short range order? See, in the beginning you see there was a regular arrangement, cation, anion, cation, anion. So to some extent there is regular arrangement, so we call it as what? Short range order. Here it is what? Long range order. Why long range order? From the beginning till the end there is a regular arrangement, so we call it as long range order, and here for some time there will be what? Regular pattern, so we call it as what? Short range order. So this is the basic definition for crystalline solids and amorphous solid. Now the second point is, these are true solids. Crystalline solids are true solids. These are pseudo solids. Pseudo solids, or they are known as supercooled liquids. Supercooled liquids. Next, number 3, you see here. Now say you know about marble, you know, and you also know about chalk. Both are made up of what? Calcium carbonate. Are both the same? Marble is hard and chalk is what? Soft. You can just break the chalk. So chalk is what? An amorphous solid, and marble is what? Crystalline solid. Why? In case of marble, the particles are arranged in a regular pattern. So the intermolecular force of attraction is what? Very strong in case of crystalline solid. But in case of amorphous solid, they are not arranged in a regular pattern. So the intermolecular force of attraction is weak. So that is the reason why you can break chalk easily, but you can't break a marble easily. Then the third portion is what? The cut portion. If you cut a crystalline solid with knife, the cut portion will have the same shape. Cut portion has same shape, but here shape is not retained. That is, if you cut a amorphous solid with a knife, the shape is not retained. But in case of a crystalline solid, if you cut it with a knife, the shape is what? Retained. Has same shape means it is retained. Next we'll study is about its melting point. Now crystalline solids have sharp melting point. What do you mean by sharp melting point? Suppose I say marble will melt at 300 degrees C. That means at 300 degrees C only marble will melt. That is, at that particular temperature it will melt. That means its melting point is what? Sharp. Or if I say quartz melts at 200 degrees C, its melting point is what? 200 degrees C. At 200 degrees C only it will change, not before that or after that. That means its melting point is what? Sharp. But in case of amorphous solids, the melting point is not sharp, or you can say melting point is in range. What do you mean by this? Melting point is in range. Suppose you just take an example, plastic. When you heat plastic, what happens first? First it will change into what? Slowly it will change into, its shape will change, then slowly it starts melting. So melting, it's not at a particular temperature. The process takes place at the process takes place in a temperature range. That is, we can say it melts from 15 degrees C to say 100 degrees C. We can't say that plastic is melting at 15 degrees C or it melts at 100 degrees C. That it's in between this temperature. First when you heat it, its shape will change, then slowly it starts melting. So amorphous solids melt in a temperature range. They are not melting at what? A particular temperature. But in case of crystalline solids, they melt at a particular temperature. That is, the melting point is fixed. Here the melting point is not fixed. So that is the reason why we say melting point of amorphous solid is not sharp. Melting point is in a range. That is when you heat. Best example is plastic, which you all know. When you heat it first, its shape changes, then slowly it starts melting. That means it comes in between temperature range. There is no particular temperature. We can't say that it melts at this temperature. But in case of crystalline solids, we can say its melting point is what? Fixed. So is it clear? So these are the 4 properties, and then the last one is crystalline solids are anisotropic. See, all of you get confused with this point because the word starts with A. So you think that it is related to amorphous. No, it's related to what? Crystalline solid. Crystalline solids are anisotropic and amorphous solids are isotropic. Amorphous solids are isotropic. Many of you get confused with the word anisotropic and isotropic, because when you see anisotropic, you think that it is related to what? Amorphous solid. So no, crystalline solids are anisotropic and amorphous solids are what? Isotropic. What is anisotropic? See, the physical properties like refractive index, which you have studied in physics, then thermal expansion, conductivity, etc. They are different in different direction in case of crystalline solids. Why is it different in different direction? You see here. Now, if you go in this direction, the physical properties say refractive index. It is due to what? The cation, anion, cation, anion, cation, anion, cation, anion, cation, anion. Okay. Now I am going in this direction. Now the physical property is only due to what? Cation. Okay. Then I am going in this direction. It is due to what? Anion, cation, anion, cation. Got it? Then here I am going again, it is about anion, cation, anion, cation. So you are getting it in, now if I go this way, you see, it's due to what? Only anion. So is it clear? The physical properties are different in different direction. Why it's different in different direction? Because they are arranged in a regular pattern. So if you are going in this direction, it is due to cation, anion, cation, anion. And if you go in this direction, it is due to what? Cation, cation, cation. And if you go in this direction, again it's due to what? Anion, anion, anion. So the physical properties like refractive index, thermal expansion, conductivity, etc. are different in different direction. So that is the reason why we call crystalline solids are anisotropic. I'll just write it. Physical properties different in different direction. Here you see, they are arranged in an irregular pattern. Therefore, what happens? The physical properties remain same in all directions. So, they are isotropic. Physical properties remain same in all direction. So, this is the difference between what crystalline solids and amorphous solids. Now, what examples can you give for crystalline solids? Marble is a crystalline solid. Then quartz is a crystalline solid. Then many examples are going to study sodium chloride, zinc sulfide. All these are what? Crystalline solids. And for amorphous, you can give examples as glass. Then you have plastic. All these are what? Amorphous solids. Glass is the best example, you see. At home you have seen your window panes and all. After a long period, what happens, you know? Glass at the top they become thin and at the bottom they become thick. Why they become like that? It's due to what? Property of fluidity. Because amorphous solids has a tendency to flow. So that is the reason why, you know, glass, old buildings and all, you see, where if the glass has become very old, say about 10 years and all, at the top it will be thin and at the bottom it becomes what? Thick. It is due to the property of what? Fluidity. Glass has a tendency to flow, or amorphous solids has a tendency to flow. So that's the reason why we call it as what? Supercooled liquids. So is it clear? So these are the difference between crystalline solids and amorphous solids. That is, in crystalline solids, the constituent particles are arranged in a regular pattern. So they follow a long range order because the pattern remains same throughout the packing. In case of amorphous solids, the constituent particles are not arranged in a regular pattern, or we can say they are arranged in an irregular pattern. So they have short range order, means to some extent they will follow a regular pattern, and after that it becomes what? Irregular. Then, so crystalline solids are known as what? True solids. Amorphous solids are known as pseudo solids or supercooled liquids. They are actually not solids, they are really what? Liquids only. Then crystalline solids, if you cut it with a knife, the cut portion has got the same shape. But in case of amorphous solids, the shape is not retained. Then crystalline solids have got what? Sharp melting point. That means the melting point is fixed. That is, if a particular quartz, it melts at 200 degrees C, means it will change its nature. That is, it will be converted into liquid at what? 200 degrees C only. That is, its melting point is fixed. That per temperature it will change its identity. Then in case of amorphous solids, the melting point is not sharp. That means they don't melt at a particular temperature. They will melt only at what? A temperature range. Then crystalline solids are anisotropic. Anisotropic means the physical properties will not remain same in all directions. They will be different in different directions. So that is clear from this diagram itself. It is due to the regular arrangement. Here it is due to cation and anion. This way if you go, it is due to what? Only cations, and here it is due to only what? Anions. So the physical properties like refractive index, conductivity, thermal expansion, etc. remains different in different direction. But in case of amorphous solid, it remains the same because they are not arranged in a regular pattern. So this is the difference between crystalline solids and amorphous solids. From this portion you get questions, and mainly it is related to anisotropic. Crystalline solids are anisotropic and amorphous solids are isotropic. What is the reason, they'll ask. So even though it's a simple topic, but you get questions from this part. Then you see, crystalline solids can be converted into amorphous solid by melting and cooling. When you melt and cool it, a crystalline solid will be converted into amorphous solid. Now we'll study classification of crystalline solids. Now in this chapter we'll be only dealing with crystalline solids and not with amorphous solids. Okay. Now crystalline solids are classified into 1. Molecular solids, then next into ionic solids, next into metallic solids, and the last into covalent solids. So there are 4 types of crystalline solids. One is molecular solids, ionic solids, metallic solids and covalent solids. Okay, so we will be dealing one by one. Now these molecular solids are 2 types, non-polar and polar. In polar one more comes, that is hydrogen bonded molecules. Hydrogen bonded. Actually this is hydrogen bonded molecules are also what? Polar molecules only, but I have written it separately. So molecular solids are 3 types: non-polar, polar and hydrogen bonded molecular solids. Now in this we are going to study the constituent particles of which the solids are made, the intermolecular force of attraction, their conductivity, melting point and example. So now we will deal with molecular solids. So they are classified into non-polar, polar and hydrogen bonded molecules. So what are the constituent particles? The constituent particles in molecular solids, whether it be non-polar, polar or hydrogen bonded, it is what? Molecules. Okay. The constituent particles are molecules. Now what is the interparticle force? In case of non-polar, the interparticle force is dispersion force or London force. This you have studied in class 11. Different types of intermolecular force of attraction. The intermolecular force of attraction existing between non-polar molecules is known as dispersion force or London force, which is a very weak force. Now in case of polar molecules, the intermolecular force of attraction is what? Dipole-dipole interaction. And in case of hydrogen bonded molecules, it's what? Hydrogen bond. So among these three, which is the strongest one? Hydrogen bond is the strongest one. And weakest is dispersion force. So next is melting point. So the force of attraction is weak. So the melting point is what? Very low. The melting point of non-polar molecules is very low. In case of polar, it is low. And in hydrogen bonded also it is what? Low. When you compare hydrogen bonded molecules and polar molecules, hydrogen bonded molecules will have higher melting point than polar ones, because this hydrogen bond is stronger than dipole-dipole interaction. Then comes this conductivity. All the three are insulators. They do not conduct electricity. Insulators. They don't conduct electricity. And examples for non-polar molecular solids, example is iodine molecule, carbon tetrachloride molecule. All these are non-polar molecular solids. Now polar, you will come across sulfur dioxide, HCl. All these are polar molecular solids. And for hydrogen bonded, examples are solid NH3, then you have solid HF and ice. So all these are what? Hydrogen bonded polar molecules. Hydrogen bonded polar molecules, that is the bond is hydrogen bond. So understood what are molecular solids? In this, the intermolecular force of attraction is dispersion force in case of non-polar molecules, and in case of polar it is dipole-dipole interaction, and in case of hydrogen bonded molecules it's hydrogen bond. In all these cases the constituent particles are molecules. Then the melting point is lowest in case of non-polar. Then polar and hydrogen bonded also it is low, but compared to non-polar it is more. Then conductivity, all of them are what? Insulators. They don't conduct heat and electricity. Next is ionic solids. In case of ionic solids, the constituent particles are what? Cation and anion. Cation and anion, that is positive and negative ion. Then interparticle force is what? Electrostatic force of attraction between the cation and anion, or electrostatic force of attraction between positive and negative ion, or we can call it as what? Ionic bond or electrovalent bond. The constant particles are cation and anion. The interparticle force is electrostatic force of attraction between positive and negative ion or ionic solid. Next, in case of ionic solids, its nature, you see, how are they? They are hard and brittle. They are hard and brittle. Then melting point, naturally when the force of attraction is strong, they'll have what? High melting point. Melting point is high. Then conductivity. Ionic solids do not conduct electricity in solid state. They conduct electricity in aqueous or molten state. They conduct electricity in aqueous or molten state. Is it clear? That is, when they are in solid state, they don't conduct electricity. Why? Because the force of attraction is very strong. So once you dissolve it in water or when you melt it, the ions move far away. So they conduct electricity. And who is responsible for conducting electricity in case of ionic solids? The ions are responsible for conducting electricity in ionic solids. Ions are responsible for conducting electricity in ionic solids. So, when you increase the temperature, the movement of the ion increases. So, what will happen to conductivity of ionic solids? It increases, because you'll get questions related to temperature change and conductivity in case of ionic solids as well as metallic solids also. So, in case of ionic solids, ions are responsible for conducting electricity, and when you increase the temperature, what happens? Conductivity is increasing. Why the conductivity is increasing? Because the movement of ion increases with increase in temperature. So, conductivity increases with increase in temperature for ionic solids. Why? Because the movement of ion increases with increase in temperature. It's a very important point. Conductivity of ionic solids increases with increase in temperature, because movement of ions increases. Is it clear? So, in case of ionic solids, the constituent particles are cation and anion, and the force of attraction is electrostatic force of attraction, and they are hard and brittle. Their melting point is high. They don't conduct electricity in solid state. In aqueous or molten state, they conduct electricity, and conductivity increases with increase in temperature. Why? Because the movement of ions who are responsible for conductivity also increases. So, two solids you have to deal, that is, next is metallic solids and covalent solids. This I will take in the next class. Okay, metallic solids and covalent solids we'll study in the next class. So just go through this much. So remaining will continue in the next class.